For this lesson, you will need your workbook, page 36 to 37, a pencil, and a calculator. We will be looking at section 2.4, the tangent ratio, in our lesson. Before we look at any examples, let's recall in a right triangle with a fixed angle x, you can label the three sides in the right triangle as the longest side hypotenuse, the opposite side standing across from angle x, and the adjacent side next to angle x. You may also recall that when we look at the three sides in the right triangle, you can relate that to SOHCAHTOA. SO stands for sine of x is opposite over hypotenuse. Ka is a cosine of angle x, which is adjacent over hypotenuse. So we looked at these two ratios yesterday, and today we will look at the very last trig ratio called tangent. So T stands for tangent of x, O over A stands for opposite over adjacent in TOA. You can copy this diagram and this relationship into the margin on page 36 to remind yourself that, well, tangent is also a primary trigonometric ratio. Now, we are going to look at a few examples on page 36 and 37 to get you started. So first of all, when we evaluate trig ratios on our calculator, if we have to find what tangent of 22.4 degrees is, depending on the model of your calculator, you will enter tan 22.4, or in my case, 22.4 tangent. Calculator display a long string of decimals, and we're going to round this answer to 4 decimal places, which will be 0.4122. Conversely, we can also use any trig ratio to find angles. So if I have a tangent ratio, tangent of angle A, equaling 0.6375, do you still remember how you can isolate for A? On your graph, on your calculator, you will notice that when you look at the tangent button, there is a tan -1 above it. Well, the tan -1 stands for the inverse of the tangent function, very similar to the inverse sine and inverse cosine that we used yesterday to calculate angles. So in question 2a, if tan A is equal to 0.6375, I'm going to enter 0.6375 and then use the second function, tan, to find out what angle A is actually approximately 33 degrees. On your calculator, you may have to enter second function tan and then 0.6375. So now we have practiced how we can use a scientific calculator to evaluate tangent of an angle or use the inverse tangent function to find the size of an angle. Let's look at a triangle and see how we can use the tangent ratio to solve a triangle or find the missing information in a triangle, in a right triangle. Number 3. Calculate the measure of angle S to the nearest degree using a scientific calculator. Alright, so here is angle S. The opposite side relative to angle S is the side UT, which is 20 centimeters. The side next to or adjacent relative to angle S is this side ST, which has a length of 21 centimeters. So now, if we want to write tangent S as a ratio of two sides from this right triangle, well, TOA tells us that it must be opposite 20 centimeters over the adjacent 21 centimeters. Using your scientific calculator, you have, well, in my case, I have to calculate 20 divided by 21. It gives me 0.9523 something something. And now I have to use the inverse tangent function to find that the size of angle S is approximately 44 degrees. So this is how you can apply TOA, or tangent of an angle, in a right triangle to solve for the missing angle. So in question 4, write the tangent ratio for the indicated angle in each triangle below. Write your answers as fractions in lowest terms. So here we are not going to need our calculator simply because we are just putting our two sides as a fraction in lowest terms. So just like what you would do in yesterday's homework, when you're given a right triangle and you're asked to write its primary trig ratios, it's very wise to first label the sides that you know, or the sides that are important to us. If we are looking for the tangent of angle D, well, the opposite side will be side EF, and the adjacent side will be side DF, which means that tangent D must be 8 over 5. Now you inspect 8 over 5, because I cannot reduce these two numbers, therefore this is already a fraction written in lowest terms. So these are the examples that I want to present to you in this video lecture. It's your turn now to practice what you know or what you have learned about the tangent ratio by completing the rest of these two pages. So questions 4B, C, question 5, question 6, and don't forget to go back to questions 1 and 2 to practice using your calculator to find tangent of an angle or angle from a tangent ratio. If you finish early, I encourage you to move on and do all the questions on page 38, 39, and 40. These 3 pages contain questions based on what you have learned in lessons 2.3 and 2.4. Thank you.